we'll be starting from the first slide, and then I'll start to explain. I just want to start with a blank page instead of right directly telling the title, because you already know it, but I just want you to think about something. I just want you to have your minds blank to the to the informations that I'm about to give. So that's why I wanted to start with the blank page. So if we want to talk about how to develop our applications, so we need to learn about new kinds of tricks and new kinds of frameworks or developing environments. And one of them was building responsive applications with RxKotlin. You might think about how can we use it and what even the RxKotlin is. So let's just, before I start, I just want to express myself so that you can understand me even more. If you're a previous watcher of Android Worldwide, you already know who I am, but Istvan, could you please move into the other right? Yes, because
Please just let me know when you want to go forward.
I'm sorry. Before I start, I just want to talk a bit about myself. If you're a previous watcher of Android Worldwide, you already know who I am. But if you're a new Android Worldwide watcher, then welcome. And about me, I'm a student at Manisa Jalal Bayar University. I'm also a LSA, which is LinkedIn Skill Assessment Certified Kotlin and Android Expert. I'm a local Compose Camp instructor for Manisa Jalal Bayar University, and I am also a DevFest speaker about Kotlin. And you can also check upon my LinkedIn and GitHub accounts to learn furthermore about myself. And now, enough for me. Now, I just wanted to have a blank mind again, and let's focus on our questions. Questions are the most effective way to understand things. If you want a question about what do you do, what are you about to do, is to make you learn and understand more about what you're going to do in your life. And so it's the same about Android development. So here's our index. Please, Istvan, please. Okay. What exactly reactive programming is, and please again, how can we make it possible on Android? That will be our two basic index questions for our slides. So I just want you to think on a blank page again. So before we start to explain what reactive programming is, we need to understand what actual programming, which is called a traditional programming, is. The traditional programming is, and you have data, and you put the rows in together in the computer, and then voila, you'll have the output. This is the traditional programming, but sometimes it might get a problem to do things up traditionally. There might be a problem and won't have the resources or the opportunity to solve it. I just want you to think on an image. Could you please move to the next image, please? This is the metro railway map of Istanbul. You may wonder, why do we need to look on the Istanbul metro railway map? But the thing is, I prepared this presentation for Kotlin of Istanbul, but it couldn't happen. So I just want you to think on a scenario here. I just want you to think on a scenario. What if the metro station of Yenikapı might have a problem there, or maybe Şişhane Beyoğlu station? What would happen? There will be a big problem on transportation, and we're talking about a city who has more than 20 million people lives in. So think about one of the most used metro stations have problems, and what are they going to do? So how can they solve their problems? Or it might have problem on the overpopulation of Istanbul, and then they might use a better solutions to reach other places of Istanbul. It goes the same as our programming. We might have problems with our data. We might have errors when we run our programs, and we might need other and better solutions. And that's where reactive programming comes in. So we're talking about the process of reactive programming is, you want to solve a problem, you don't need to go from the traditional way. You can solve the problem directly. As you can see from the diagram, Istvan, please. Okay, if you can see the diagram, you can see the error right over there, which is a red dot. But if you follow the traditional process, you might get restricted by the error. But if you can click on the representation of the error and just move along from it, you can overcome the error. Even just for the moment, you can overcome it. That's what reactive programming makes us to overcome our problems much simpler. Okay? Now, Istvan, please. I just want you to talk about a library. Istvan, please. What do you know what this is? Yes, it is reactive X. Istvan again. reactive X is a revolutionary library. How revolutionary it is? reactive X created us opportunities to overcome our problems and just go walk around it, and it just makes us understand our programming processes even better. Istvan, please again. You can see the process of two variables. I call them variables, and two sides actually, a subscriber and observable. What are those? Subscriber is you, the user. Subscriber subscribes the observable, and observable creates on next and on complete, on error methods for the subscriber, so that subscriber can understand the errors or the process, and then they can use their data even better, because observable creates data for subscriber, and they to make the process better, they make their own process by their own methods. That's why it's called an operator. Istvan, please again. Why it's called operator? Because observable really operates the whole process and makes it all possible for the subscriber, which is the user. Istvan, please again. Here you can see from the code, you'll see this message stream of that comes from the observable. You can fetch the messages, and you can schedule it, you can filter it, you can map it for its content, and then you can show the subscriber, that is you, the messages even better. Istvan again, please. This is called a marble schema. Why it's called a marble schema? Because it looks like when we're playing marbles, you know, I'm a Turkish myself, and I used to play marbles a lot. And if you just push it to the marble, goes and pushes all the marbles all over the area. Why did you turn it? Could you please turn it again? Okay, thank you. I just pushed it. I didn't mean to change the slides. I just wanted to explain something on process. I mean, from their timeline, they can manage things up by their own ways, and they might how can I say, scramble things up. But this scrambling things might get into a new order. I mean, it goes the same as I think. You know, there's an observable, there are the items, there's a vertical line, and there are the boxes that can manage our operations, and there will be an error point if for a reason observable terminates abnormally, and the result is the transformation. That's why it's called the marble schema. I mean, just you shoot it, might get scrambled, but in the end, gets into the order. Next one, please. So when we continue to talk about observables, we need to look on click. Okay. Can based on its emissions. Observables are based on two specialities, and one of them is emissions. And click, please. You can create on success or on error, and you can emit the data, the fetchments, and our process to creating solutions when it comes a problem in our program. And then we continue to explain the emissions. It might get a little bit complex. So click, please. Click again. And then based on its behaviors, I mean, let's just think about your child or your little brother or sister, and you just try to behave themselves. If you're not if you're a behavable parent or a behavable brother or sister, you just need to control yourself. You just don't need to push him or her hard or something like that. Just try to do it simple and with a smiley, much more sympathy. And if we're talking about their behaviors, again, we can talk for their behaviors. I mean, there may be a problem, but you can form it from the our box. You can manage to get into the timeline. That's why, as I said before, just push into the marbles. It might get scrambled, but then in the end, it might get into the order. Okay. So now we'll learn about the basic processes of how can we make difference? Now we'll learn about the basic processes of reactive programming and also the reactive X. Now, how can we make difference? How can we make our programs even better? We can use reactive X to filter. We can filter our, again, it just needs to show up from the schema. We can filter up what we do in our programs. I mean, there might be a problem with our variables. So then we can filter up, and then we have our filtered, but less complicated and much effective way to solve our problems, to create a solution. And then we can combine. I mean, we can use unfiltered, but why do we need to combine? Because there might be not only way to solve our problems, we need to merge them up, because some of the programs might have more than one input variables. So we need to merge things up to create a better solution. And then we can use and we can handle our errors. As I said before, it's the most effective way to use our reactive programming processes. I mean, there might be a problem on our error points, and we can catch them using reactive X, and then we'll get into them into a better timeline again. It's like you're becoming the Doctor Who, the show, and he just moves from the timeline to create solutions like him. And you can see from the, could you please move? Yeah, no, again. You can see from our main basic code. Here we see the disposable, which is created from the observable, and we can see the emissions, and we can see how emitter will react when we complete our events, and we can fetch our data, can receive it, or it might have a problem, as I said before, and then we can finish our process, and then we created an information between our programs and our users. So now we are here again to ask questions again. Are there any other options? Well, there is. Of course there is. I mean, RxKotlin or ReactiveX libraries are open source libraries that anyone can use to create their application, but it is a third-party solution. You can use coroutines as well, but coroutines is a bit different, but it might sometimes get the job done better than RxKotlin. And why should we choose Kotlin, RxKotlin? I mean, if you're okay with using third-party libraries, and if you're okay with fetching data and merging and and you're filtering up your program, or you just want to handle your errors even better, you should definitely use RxKotlin. And it has come to end for my presentation. Thank you for listening. I hope I didn't get into so much trouble, and I would love to hear your questions from you. Thank you.
Thank you, Sarp, for the presentation. And we have comments. Please, Kimi or anyone else, if you can show them, we could try to answer them. I mean, mostly you, Sarp.
Okay. Okay.
So what strategies or best practices can be used to guarantee data integrity and avoid race conditions, from Mahmoud?
The best strategies is to be, I think, using better servicing and using better asynchronous operations, because it's not really the best solution to use a more lightweight data. I mean, you might need to use a bigger data. So I mean, if you are working with a streaming service, it might need to attend on a huge data loads of films, TV series, or something. I mean, as a Turkish myself, there are lots of films and TV series that we want to watch. So if we're talking about huge loads of data, we just try to use asynchronous operations rather than, how can I say, squeezing up our data. We can give them their freedom, and instead we can work on the information, the messaging between the user and the data layer, instead of working on the data layer itself. I think that way, at least.
I hope, Mahmoud, that answered your question. Are there any other questions? Okay, from Geeky Jimmy, how do RxKotlin and Kotlin coroutines differ in their approach to handling concurrency?
So, coroutines mostly work as a heartbeat. Just how can I say, bop, beep, bop. Coroutines work that way. I mean, just on one way to another, and to another again, to the same way that you previously worked on. So that's how mostly coroutines work. But RxKotlin mostly interested in and massaging between the subscriber, which is you, and the observer, which is data layer. So the best way to use RxKotlin is to make asynchronous operations, and the best way to use coroutines, you just need to understand how your heartbeat goes. That's all I can say. I mean, I'm good at some metaphorical explanations. That's how my style is.
Yeah, that was a good one, actually. If you can imagine the EKG,
Yes.
sinus rhythm, something with threads.
Yes.
Okay, we still have some time, so if there are more questions, if you want to answer them, then we can still display some.
Sure, why not? I mean, if I can explain myself good for the for the audience, I'll be pleased.
So if we can put up another question, then Kimi, please do. Let's wait for a couple of seconds.
Well, if there ain't any, I just that there won't need to push people up to ask their questions. If they don't have any questions for the presentation or the process of reactive programming, then I guess I did my job well done. That's all I can say.
Then thank you so much for presenting here, and thank you for answering
it
the
is
questions.
it is my thanks. It is my thanks because I had so much trouble there, and it was so troubling experience for me. But let's hope all for the best, and let's hope all for the best for our developing skills and our developing processes. That's all I can say. Thank you so much, and